Today I'm gonna do a video presentation of the work I read, which is called Minecraft Computer Game Performance Analysis and Network Traffic Emulation by a Custom Boat. And there are two purposes of this paper. One is aims to realistically emulate network traffic that a normal human player would generate while playing by using custom boat under GPU infrastructure. And the second one is to find out the maximum possible workload on a virtual multi-core server under the same situation. But actually, their experiment environment was built based on a previous work, and basically they are running under the same situation. So before I go into this paper, I'm gonna introduce the previous work a little bit. The previous work is called Minecraft Computer Game Simulation Network Performance Analysis, and the whole experiment is implemented under GPU infrastructure as well. What GPU does is to connecting player to common game servers across the internet. Meanwhile, GPU servers would reroute your game network traffic through a faster route by picking like better route by its own intelligence algorithm. So that GPU could provide user higher quality of connection, which means a stable ping connections here. And they use Minecraft as a game to test. Why use Minecraft? Because Minecraft is a sandbox multiplayer online game, and it is well Java documented, so it can provide really comprehensive network traffic, and it's easy to be predicted as for its network behavior, because the documentation is very their documentation is complete and easy to read and well defined, so it's good for test. And the whole experiment environment was implemented under virtual environment. That's to say, virtual machine and virtual local area network. And thus, it can isolate the real-world internet from purely routing on the server's elements of game latency. So, but actually, by the limitation of the resources at that time, they can only use passive boat in the game, which means the boat cannot move or do any complicated action in the game. And it also restrict the comprehensiveness of the experiment result at some extent at that time. And this is the infrastructure architecture of the whole network environment. Basically, there are 5 components, as you can see. First is client and routers, node server, traffic monitor. Basically, client is the machine who is running the game, and router is just router. And the node here is a machine who is running the GPM software, and server is the machine who emulate the Minecraft game server. And traffic monitor is another physical machine who is responsible for collecting data and analyzing. Each component is running under a Linux system, although the operating system that may affect the network performance, but Linux system actually would have better network performance than Windows or Mac operating system, but this is not focus of this paper. This is a physical design of the infrastructure. As you can notice, there are two identical virtual network here. The first one is a normal one, just like, and the second one is used for running the task in a parallel, in a quicker way to collecting and running tests, to collecting data and running tests. So under normal condition, the network traffic would go out from client replay here and go through VLAN 10 and go through router here. As long as it reaches router here, the network traffic will be reroute to this node here, which is running the GPN service, and goes out to back to the normal route and reach the game server at the end. And at the same time, network data and latency can be tested through this machine, who's running the GPN service here. And there are some facts I want to mention of this previous work. The first conclusion they get from the test result is the idle players, no matter it's a bot or a human players, would generate 70% traffic as a human player would. This is not surprising, but if multiple idle players in the same area and were interacting with each other in terms of exchanging acknowledgement and information among them, it would generate 200% network traffic as multiple active player would generate. So that is to say, idle player can actually consumes more network resources than active player. So this implies GPN developer that in the future they could consider add features to the software that allow it detect idle behavior and minimize the number of idle connection to relieve the network condition. But actually, the interesting fact is when they measure the idle players and active players, actually it's not together. When they measure along, they produce same amount of traffic. So that's quite an interesting fact. And there's another more important fact they found is that most latency incurred is actually due to server and router delays. So not by bot or player action in the game or interaction or anything else, just due to server and router delays. So this paper stopped their experiment by this point. So that's where I generate some question for them, because they do use GPN service in the experiment, but actually they didn't investigate how GPN interacts with the network traffic in the experiment, and or how GPN improves the network traffic in any ways. There's no result or conclusion mention GPN. So I started to think if the work had been done in the current paper, would investigate the GPN further or not. Let's just find out. The environment used in current research is exactly same as the previous one, but there are two differences. The first difference is that this time, instead of using passive boat, they use two types of boat. One is called chat boat, and the other one is their self-developed boat. The chat boat is very similar to the passive boat. It cannot do um, advanced action in the game, but their self-developed boat are pretty functional. The boat can move in the game, can place objects in the game, can even break the objects in the game, and can chat in some ways in the game as well. So they can perform more advanced functionality than previous one. So this time they got more comprehensive results by their self-developed boat. And another difference is that in order to find out the threshold of the server side, they manually configure that let server running on a 8-core physical machine and let a server running only using 1 core at a time and assign 20 volts to each server. So under this implementation, they found out a really valuable result. Let's find out what they found. As you can see from the graph, they are so for the first this pillar here. This pillar here means that if there's one server running on 1 core, 52.95% of the CPU was utilized. And if let's see, if 3 servers is running simultaneously on 1 core, almost more than 100% of the CPU was utilized. There's more aggressive deployment. Let's see. From the first pillar here, we can see if there are 2 servers running on 1 core and 2 servers running on another core, then 100% CPU utilization will be used by those 3 cores, and more than 80% of CPU utilization will be used by 2 cores. And let's see here. This is the last pillar here. This basically means if each core is running 2 servers on them, so basically 2 servers is deployed on 8 cores each, then each core will be utilized more than 80%. So that within the current paper, they found another important fact is that if your CPU usage was above 90%, the client side will suffer severe latency. On the other hand, we can also conclude that if each core is running on 2 servers, and then the utilization would be, let's say, would be below 90%, then which means with a 8 cores multi-core server, it can allow 16 up to 16 game servers running on that host, and this result can be really valuable when implement similar infrastructure in realistic environment, especially in terms of servers implementation. But still, I believe further work is needed to expose the mechanism of how GPN works, because the major advantage of GPN is actually finding optimized routes through internet. So retrieve result by this work by isolating environment will not be so convincible. So set up experiment by using a geographically remote server can be one of the works need to be done in the future to scientifically understand how GPU works. And maybe that's all of it. Thanks for watching. Thank you.